Hello everyone, welcome to the webinar today. I'm going to be talking about scaling DevOps. Hopefully I'll go on for about 40 minutes and then leave plenty of time at the end for questions. Before we start, I just wanted to announce that I will be speaking in Chicago on October the 21st at a lunchtime event, and in San Francisco on November the 11th at a breakfast event. If you're interested in coming to those, they're designed for senior management and executive level people. Please send your details to CSouza, that's C-S-O-U-Z-A, or C-S-O-U-Z-A, since we're in America, at ThoughtWorks.com for more information on those events. So, scaling DevOps. Why is DevOps important? I think mainly because we're seeing a lot of competition in the space of creating strategic software. There's a bubble in Silicon Valley. People are finding ways to deliver software faster and more reliably. And medium and large organizations are feeling a lot of pressure. Traditional methodologies for delivering software, it takes months or even years to deliver software and create new versions of software. And I'm going to spend a bit of time today looking at why that's the case and what we can do about it. And DevOps is part of the solution. So there was a report in The Economist by the Economist Intelligence Unit recently where they talked about business agility and organizational agility, how businesses can survive and thrive in turbulent times. And one of the major reasons they gave for why it's hard for businesses to respond rapidly to changing market conditions is as follows. The main obstacles to improve business responsiveness are slow decision-making, conflicting departmental goals and priorities, risk-averse cultures, and silo-based information. So that should be familiar to many people working in medium and large organizations. So let's dive into a bit more detail about why that's the case. In order to do that, let's consider what an enterprise looks like. And this is my kind of very simplified diagram of an enterprise. You have the business, which is responsible for making money, and you have IT. And IT is normally split into an engineering or apps department where a bunch of projects are being run, and an operational department where the systems that are actually live in production or released to users are managed and maintained, and they have DBA, service desk, infrastructure team, management, so forth. And up in the top right, you can see a diagram showing a bunch of systems working in production. Martin Fowler assures me this is valid UML for a big ball of mud. And this is a snapshot of a point in time. And it's a relatively simple enterprise. There's no centralized testing department, for example, in this diagram. We're not showing teams distributed between multiple different locations. So in that sense, it's relatively straightforward. So this should be kind of familiar to you, but there's a problem with this model. You want to, and there's obviously the machine that goes bing that tells you that everything is working. When the business wants to create a new product or a new service, a project is spun up in order to actually service this request. So that project builds a system, and then after many months, maybe even years, that system is deemed to be ready, and it's released with much blood, sweat and tears to users, and it's hooked up with all the other systems. It's thrown over the wall to operations who then manage it. And one of the main problems with this, just this particular part of it, is that means it takes a long time before that system, that product, that service is actually delivering value, months or years, before you get feedback even on whether the thing that you built is actually useful. Now, obviously, you have to go through a process in order to build a project, to build a system, or to finance a project to build a system. You have to produce a business case. There's all kinds of approvals that have to be gone through so you can get budgeting to actually start work on that project. But even so, all that really is doing is guessing. We think this might be valuable. People may pay money for this, and these are the features that we think people will find valuable. And it's only when you actually release it to users that you find out if you're actually going to make money out of it. And, well, organizations often measure whether projects are successful in terms of did they deliver things on scope, on schedule, and within the budget. It's not necessarily common to measure whether the project or the service was actually successful in terms of ultimately over the course of its life cycle, did it make money for the organization? And if you measure projects according to that metric, often they're not very successful. And the key really to improving the success rate of projects over their life cycle is to get feedback from early on about what's going to be valuable. And the project metaphor is very bad in this respect, because what tends to happen is you want to deliver a project with as much functionality as possible, because it's hard to get a budget and it's hard to spin up a project. And so you get the budget and you want to put as much stuff as possible into that before it's released, because it's going to be hard to change it afterwards. And so what you get into is what's called the large batch death spiral. You put stuff into the project and then you're worried, is it actually going to work? Is this what people actually are going to want? And you keep putting more and more stuff into it to make sure that it's really going to be successful, and the project gets longer and longer, and then you have to start cutting scope. And it's very difficult to cut scope at that point, because you've invested so much in it, you really don't want it to fail, and cutting scope is kind of almost tantamount to admitting failure with the project. So people put more and more stuff into it, and that pushes the data out, and this just exacerbates the problem. So what can we do to help fix this, to help resolve this problem? Well, often the solution is, yes, and again, once you've released it, there's a machine that goes ping. One response to that is to go Agile. And indeed, this is what Agile is supposed to do. Agile is supposed to improve the success of building software. But what's the reaction of the rest of the organisation to this idea that we're going to go Agile, that we're going to start delivering earlier and more frequently? Well, often the rest of the organisation isn't very keen on that idea, for a couple of reasons. Firstly, it's a lot more work for the business to be involved in an Agile project if you're doing it right. Because what happens is the business is supposed to interact much more closely with the engineering team. I mean, we write stories rather than requirements, and stories are simply supposed to be a reminder of a conversation. And when you actually develop that piece of functionality, that story, you're supposed to actually then go and talk to the business and make sure you're really doing what they want, get any new information since the story was written, showcase it to them, get feedback, build that in. And it's a much more intensive process that requires much more business involvement. It's not very widely known fact that on the very first XP, or widely known XP project, the Chrysler Comprehensive Compensation Project, the product owner had to take time off due to stress because of the amount of work that she had to do in order to support the engineering team. So it's a lot of hard work for the business. And it's also a lot of hard work for operations, because operations is measured on the stability of the production environment. That's how they get compensated and they get measured. Is the system stable? Changes to the production environment are risky because they can go wrong, and that can decrease stability, it can lead to downtime. And so operations equate change with risk, and Agile means more stuff coming their way more frequently. So operations isn't necessarily very keen on Agile either. I mean, you're building these projects and then you're releasing them more frequently into the operational environment, and that's painful. Now, the reaction of engineering to operations not liking their new Agile methodology is often somewhat defensive. The engineering team says, well, listen, we're doing test-driven development, we're following solid engineering principles, we're making sure our systems are well encapsulated and loosely coupled. What's the problem? And operations have a response to this. Well, that's very nice, but it's a shame your stuff doesn't actually work in real life. Maybe you could fix that, please. And so really what we need to do is find a way to involve operations and the business more closely and get them bought into it and build up their trust that actually this is a way to improve things for everyone. Ultimately, everyone has the same goal: business, engineering, operations, IT in the business. And that goal is to produce software that is strategic, that delivers value to the business. That everyone has the same goal, but because we're measured in different ways, engineering is measured according to throughput, operations is measured according to stability, these conflicts are very, very common, despite the fact we have the same goals. So what can we do about this? What can we do to work together more effectively? Well, this is really the goal of DevOps, because what typically happens is when operations doesn't like engineering, they put they erect further barriers to prevent engineering from putting out new releases. So you essentially, operations adopts ITIL, and they focus on the parts of ITIL that make it hard for engineering to do releases. So they put up this barrier and create this change management process, which makes it harder for operations to release. So DevOps is supposed to be a solution to this problem, and DevOps was developed in response to this problem. And people have been doing a lot of the stuff that DevOps talks about for a while. It's just that we never had a name for it. So we've got this name now, and it describes things that many of us have been doing for a long time. So what is DevOps? There's 4 parts to it, really: culture, automation, measurement, and sharing. I'm going to talk about each of those different aspects in turn. So first of all, let's look at culture. And culture is really the most important part of DevOps in many ways. It's about making sure that operations and development are working together, and that they are working together efficiently, and they're not treating each other as rivals or as enemies or as people who make their life worse. And the best way to improve cooperation between the two groups is to have them work together more frequently. Which may sound like a terrible idea if you're working in one of those departments and you really don't like the other people. But actually, there are ways to involve the other people earlier on in the process and throughout the process, and that leads to significant improvements in cooperation and in stability and in successful releases. So you can have operations people go to development meetings, inceptions, showcases and retrospectives, for instance, so that operations have a chance to see what's coming down the pipeline and feed their requirements into that process. Often operations people get upset because their requirements, such as monitorability, scalability, the ability to archive data and so forth, don't get built into the requirements for the project in the same way that the other functional requirements get built in. So a great way to help address that is to have operations feed their requirements in as part of the inception process for a project. However, operations people are often pretty busy. Operations departments are often firefighting, and they don't have time to do strategic work because they're too busy trying to make sure things are working. So the other thing you can do is have developers go and work in the operations department. Have developers go to operational meetings. Have developers rotate through the operations department. That's one way to get developers to understand the world of operations and some of their problems. Another thing which is insufficiently common, I think, is having developers responsible when releases go out, having developers on call, having developers carry pages. One of the things that Facebook do is they have the developers actually carry pages so that if there's a problem in prod, the developers get called up and they have to help solve it. That's a very effective way to get developers creating more production-ready systems and building stability into the system if they know that they're going to get called up in the middle of the night when something goes wrong. And what a lot of this stuff is about is making sure that you're organising your incentives. As I said earlier, operations are measured according to stability, development engineering is measured according to throughput. What if developers were measured according to stability and operations were measured according to throughput? You would then see some changes in the way that the two groups interacted. So people behave according to how they're measured. So think about the way you're measuring people and if that really is encouraging the correct behaviour in your organisation. The second key part of DevOps is automation. And really what this is about is reducing the transaction cost of making changes to your systems, making it cheaper and less risky to make changes to your systems. One of the things that is I'm going to talk about a bit later is the importance of batch size and the importance of reducing batch size when you're delivering software. And the key to reducing batch size is reducing the transaction cost of actually making changes. And this is where automation is really important. The first and most important thing is to create a deployment pipeline for your applications, and that is to automate the build, deploy, test and release process. Every time you make a change to your system, whether it's the source code, the configuration, database schema, the scripts, the test scripts, it should kick off a continuous integration build, which builds the system and runs some tests to verify whether the change broke anything. And that should be a fully automated process. It should be possible to do a push button deployment to any environment that you have access to, and even release to production should be a push button process that's fully automated, that's been tested many, many times before by deploying to production like testing and staging environments. This deployment pipeline is what allows you to evaluate the risk of every change before it gets to production and make sure that everyone knows what the risk of every change is. It's a way of improving the transparency of your delivery process and improving the transparency of your risk management process. And the deployment pipeline has many other important benefits, such as giving you a fully auditable process for getting changes from source code through to release, and being able to audit and ensure compliance for every change that you make to your systems. The second key piece of automation is in provisioning and management of infrastructure and environments, making sure that it's possible to recreate production-like environments using a fully automated process, using tools like virtualization, cloud computing, tools like Puppet and Chef, which allow you to declare what your configuration of your environment should be in version control, and then have the tools actually install the various packages and configuration files to bring those environments and infrastructure up to the correct configuration. That's important because one of the keys to low-risk releases is doing testing in production-like environments before you actually release to production, and doing that all the way through the process. And then the third key aspect of automation is automating database migrations and deployments. And again, none of this is suggesting that the deployment should be done without approval. Approval is essential. You need to be able to make sure all changes are approved using your standard process. But once they're approved, the actual deployment should happen using a fully automated process in order to remove the risk of error and remove the risk of anyone doing anything that they shouldn't be doing. So these things together make it much easier to validate the effect of any change, the risk of any given change, and to prove that that change is low risk, and to get feedback early on if any particular change is going to be higher risk, so that you can take additional steps to prevent any problems when you release it. And secondly, it reduces the transaction cost of your delivery process, so you can release more frequently. So the third aspect of DevOps is measurement, in particular measuring business metrics. It should be possible when you put out a new release of your software to measure the delta in terms of, are we making more money out of this new release? Is it resulting in more orders or more users in the system? From day one of your first release, you should be able to measure how much money are we making from this system, how many people are using it. Real end-to-end business metrics are key, so you can get feedback. And then additional changes, you should measure the delta in those metrics so that you can see whether what you're doing is really valuable. Since we're talking about improving stability, you should be also measuring ops metrics, things like time to detect failures, time to restore service, all those numbers, so that you can make sure that as you go through a process of relentless improvement, of Kaizen, that you are actually making things better. There should be a feedback loop there. There's also technical metrics that you can measure that's very important. There needs to be a feedback process, even with measurement, which is to do root cause analysis. When something breaks, when something goes wrong, what are the root causes? And how do we improve our process to prevent them happening again? Maybe we need to add more tests. Maybe we need to do more automated testing in order to make sure these problems don't occur again. Finally, sharing knowledge, making sure that the knowledge that the operations people have about the systems is shared with the development team, making sure that development techniques like behavior-driven development, test-driven development, refactoring, continuous integration are understood by operations teams, because they can be used for improving operational environments and evolving operational environments the same way they can be used for evolving development systems. Making sure that simple things happen, like when a project is successful and you go out and have a party, the operations people are invited as well. Simple things like that can make a big change to the relationship between development and operations. If the operations people feel like they're getting if they're getting to share some of the success, that can make them more sympathetic towards you and help build up trust. So these are all things that can be done from the bottom up by people just deciding, well, guess what? We're going for lunch, let's have the ops people over for lunch. If the ops people are going for lunch, let's invite some of the developers along for lunch as well. Simple things like that can help build up trust and improve the relationship between dev and ops. And when you do these things, you improve culture, you start automating some of your delivery process, you start measuring more things and feeding those measurements back, crucially, to everyone involved in the delivery process, and you encourage more sharing between the various teams. What you find is that the border between operations and engineering becomes more porous, that those two groups work together more, and they work together throughout the life cycle of the services or the products that you're building. And this is encouraged by ITIL v3. ITIL v3 says that operations should be involved right from the beginning of the delivery life cycle, not just from when things, or just before things get released into production. So this is better, this is an improvement, but it still doesn't solve all our problems. What it does do is it helps enable continuous delivery. Continuous delivery was covered in the first webinar in this series by my colleague Rolf Russell, and I'm not going to talk about it in detail, but I'm going to give you some pointers. In continuous delivery, the idea is that developers write production-ready code. They make their systems deployable from day one, and they deploy to production-like environments from day one to make sure that their systems are actually stable. They will actually achieve the required performance, they will perform under load and so forth, so that you're not doing kind of hardening or stabilization after your dev complete phase, which is a common anti-pattern that you see, which is very problematic and leads to a lot of volatility in schedules. So again, you're measuring developers partly according to the stability of the systems they create. Have developers write production-ready code and prove that it's production-ready by deploying it to production-like environment from day one. Everyone collaborates together throughout the life cycle of projects so that some of these problems we talked about earlier are resolved early on. Continuous delivery is all about encouraging rich, fast feedback loops. There's feedback loops when you check in because unit tests get run to prove that you haven't introduced a regression. You have automated functional tests to prove that your software meets its requirements as its user-facing requirements. You have feedback loops from testing back to development that happen very rapidly. You get feedback from production-like environments to developers as early as possible. And of course, the most important feedback loop, the feedback loop from users to your teams, your engineering and business teams, making sure that those feedback loops come as early as possible and are as rich as possible, so that you can respond rapidly to new information and so that you can get new information on what you're doing as quickly as possible. That's really the core of continuous delivery. That leads to lower risk, more reliable releases, because you're making sure that you identify risks and manage them much earlier on in the delivery process rather than waiting for dev complete. And you're testing your release process much more frequently so that you can remove problems early on. Continuous delivery is a great way to reduce the risk of releases and make them more reliable. And finally, the key point of continuous delivery is we get rid of this idea of dev complete. Work isn't complete until it's released to users, or at the very least until it's being deployed to a production-like environment and subjected to a realistic production-like load. So that last point, done means released, means you need to change the way you think about project management. And I'm going to spend a few minutes talking about project management and what this stuff means for project management. So it's very common in project management to focus on constraints: cost, schedule, and scope. Those are the three corners of the traditional approach to project management. You want to make projects come in on schedule with the agreed scope and on or under budget. But actually, when we think of our products and our services, that's really not the most important thing. The most important thing is that what we're doing is valuable and that it's high quality. And that doesn't mean internal quality, it means that the system is reliable, that it's adaptable, that it can be changed and maintained. And so I want to focus a little bit on value and quality, because that's really the goal of software development, is to produce valuable, high-quality software, because that's how you actually deliver business value. That's not to say that constraints aren't important, but usually they're not as important as those other things. You know, if you deliver something on schedule with the agreed scope and under budget, but it doesn't make any money because nobody actually wants it, it's kind of pointless. So that's why it's important to think about value and quality as well as constraints. And when you consider those two things, really there's only one constraint that you can take account of. And the most important one in most situations is schedule. And again, one of the goals of continuous delivery is to reduce the time to market, and that means controlling schedule. And when you control schedule, what you're also doing is controlling cost, because you're making sure that you don't get into the large batch death spiral, which is what is the main cause of increasing cost. And scope will go down, but then you get the opportunity to add more scope, and you get the more safety knowing that the scope that you're adding is actually valuable. So let's talk about value and quality. So first of all, value. How can we add value to our software delivery processes? The most important way to add value is to do less. One of the most insightful reports early on in the evolution of Agile was a Standish Group report that was delivered at XP 2002. And that report said, or showed, that far more than 50% of functionality in software is rarely or never used. These aren't just marginally valued features, many are no value features. And this report was performed based on studies done on the Department of Defense and many other large enterprise organizations. The biggest source of waste in our software delivery process is building stuff that is never used or rarely used. So it's important to do less, to focus on delivering what we think is the highest value stuff as fast as possible and getting feedback from users to determine what to do next, so we don't waste our time building stuff that people don't want. The second thing to think about is quality. And again, quality doesn't exist in a vacuum. There's a book that's come out by Eric Ries called The Lean Startup, which came out this month. I think it's going to be one of the most important business books this decade. One of the quotes that I really like from that book is this: if we do not know who the customer is, we do not know what quality is. And one of the implications of that is that we cannot know what the quality is until we've released it to our users. So again, I'm trying to emphasize the importance of releasing something early on in the process to users so you can determine what the quality and the value of what you've done is. Now, there's also internal quality, and that's important as well. And one of the quotes the quote that I like the most on quality comes from a guy called W. Edwards Deming, who is one of the founders of the Lean movement. And what he says is this: cease dependence on mass inspection to achieve quality. Improve the process and build quality into the product in the first place. And this applies to software as much as it applies to manufacturing. And it has two key implications. Firstly, quality or testing, quality assurance is not a phase. It's not something you do once you're dev complete with the software. Testing is something we should be doing all the time, not just when we're dev complete with something. Secondly, quality is not the responsibility of testers. Quality is the responsibility of everyone, not just testers. So developers are responsible for quality. Managers are responsible for quality. Operations, the business, everyone is responsible for quality, not just the testers. Testers serve an important and vital role in the software delivery process, and that is making the quality of the system transparent. But they are not responsible for the quality of the system. Everyone is. And when it comes to ceasing dependence on mass inspection, what's mass inspection in the context of software delivery? It's regression testing. So one of the key practices that follows on from this is that testing is not something that should be done. Regression testing should not be done as a phase after development. Regression testing should be automated and run against every change, which is the point of continuous integration. So, we talked a bit about value, we've talked a bit about quality, and we've made some changes to the way that engineering and operations collaborate in order to make sure that we're delivering high quality, valuable stuff more rapidly. However, there are still some important problems that we face as organizations. Firstly, we might change the way we're delivering new projects, but operations still has all that crap in production. And that stuff is painful to maintain. You might be running your mission critical systems on hardware or platforms that are old, that you're not using for new development. Sometimes I've seen, in fact, far too commonly, I've seen production systems running on hardware or using software that's no longer supported by the vendors. In some extreme cases, I've seen people running mission-critical systems where the source code to those systems has been lost. This is surprisingly prevalent in organizations, and operations has to run and maintain that. In the most recent Forrester report, they have a report where they measure MOOS, which is the amount of spending on operations. Only 29% of the IT budget was being spent on delivering new systems. 71% of the IT budget was spent on maintaining existing systems and adding capacity to existing systems to meet increased demand. That is unsustainable if you want to compete in the market, but it's a symptom of the fact that operations are spending a lot of time running these mission-critical systems, and the worst thing is that there's no way to rationally decide how to retire those services and replace them. In the software delivery lifecycle, in the service management lifecycle, there's a retirement phase. How many organizations actually retire their services? It's very uncommon. And part of the reason for that is because it's very hard to rationally decide what to retire, because it's very hard to measure the cost of any given service on a per service basis, because it's very hard in that operational budget to say, well, how much money are we spending on each individual service, and how much money is each of those services actually making for us? And because you can't get those numbers, because it's all rolled up into a single budget and it's hard to decompose that budget, you can't make rational decisions, which is why it's very hard to retire things. Decisions on what to do next are still done in a command and control way. It's as if you're running your organizations according to a kind of Soviet centrally commanded economy plan, and that's a response to the fact that there's not enough information on what the value of the things we're building is, how much they're costing us, what the value of the projects that we're going to build will be when we release them. All that stuff is based on guesses. So there's a dearth of data and information on what decisions to make. So people still do this thing in a command and control way, and it's very, very inefficient. And it's a big source of waste in organizations. So wouldn't it be better if we applied market economics to our decisions on what systems to build, what systems to retire, and what systems to do more work on, what systems to mothball for a while? Wouldn't it be better if we made those decisions based on real-time economic data? And that's what I'm going to talk about next. And the other problem is that changing to a model where you do this is painful, because often the people who can make the changes aren't the ones feeling the pain. The people who can make the changes are normally senior management, but often it's the people on the ground, operations people, developers, who are feeling the pain. And again, I'm going to talk about how we would address that. So Amazon have dealt with this problem and had to feel this problem, and they had to respond to this problem because they faced a business imperative. They had to grow, they had to make money, and they were going to go out of business unless they did so. And Amazon has a very simple solution to these problems. You build it, you run it. What Amazon did is they took their big ball of mud architecture and they split it into services. They created a service-oriented architecture. And there were some important characteristics of that service-oriented architecture. Firstly, each of the services was user-facing. So there wasn't a service which talked to the message bus and created some numbers for another service to consume. Those services are user-facing. So you have things like a product catalog service, you have a shopping cart service, you have a recommendations engine service, you have a commenting service. All these parts of the Amazon website are services. And those services are managed by teams which are responsible for those services through their entire life cycle. So the team that builds a service is the same team that runs the service throughout its life cycle, and ultimately the same team that retires that service. And that made a huge difference to Amazon's ability to evolve their systems and to get real-time, true economic data on what the value of each of those services was, and the cost of those services, and where to spend their money. So the idea is this. Take these services that you have in operations right now, and particularly new services, and instead of treating them using the project metaphor where you build them and then you throw them over the wall to operations, treat them like products. Have engineering teams building products and a team dedicated to each product, and build your services as if they were products. And instead of using project management, use product management instead as your paradigm for building them. An aside at this point, the book that I've read this year, which I think is the best book I've read in a while on the software development process, is a book by Don Reinertsen called The Principles of Product Development Flow, second generation lean product development. If you're wondering what the difference is between project management and product management, I urge you to go and buy this book and read it. It's a really, really great book, and one of the best books, well, certainly the best book I've read on software delivery this year. And so when you do this, it changes the way that you can measure the value and the cost of your systems and the way that you make decisions as an organization on what to do. Those product teams can measure the cost and value delivered on a per product, on a per service basis. That means that teams can rationally determine what they're going to prioritize. If you're delivering early and then getting feedback from your users, and the business is co-located, if the product owners are co-located with those product teams, then those teams can make much faster decisions on what to prioritize and what to do next, based on real economic data. Teams can manage themselves. And again, the other book that I think is important is the Lean Startup book. Teams can manage their own work using the Lean Startup methodology, which focuses on getting a minimum viable product out there and building new features in response to real data from customers. There's still a role for the architecture group and the PMO. The architecture group is responsible for the cross-functional attributes of the system, things like making sure that it meets the system as a whole, performs and scales, and that the architecture is flexible, that you can do integration testing early and frequently, that you're not going to be running a bunch of different systems that are hard to maintain. So the architecture group is still important, and it's responsible for regulating and monitoring system level attributes. And the PMO still exists as well, but the point of the PMO is this. Anytime you have a free market system, it operates within certain limits, and once you go outside of those limits, the market economic system doesn't work, as we discovered quite recently. So the job of the PMO is to prevent market failure and to manage externalities and make sure that actually the data that's feeding back into those product teams acts in such a way to align those teams with the goals of the organisation as a whole. So this demands organisational change to the architecture group and to the PMO, as we've discussed. It also demands change to the way that the operations group works. So in this model, you still have an operations group, a centrally managed operations group, but it's no longer responsible for managing applications once they're put live, and it's no longer responsible for level 3 support for those applications. That stuff goes back into the product teams. The job of the operations group is to manage the infrastructure that those systems run on and provide infrastructure as a service, much in the way that Amazon Web Services is actually managed by a group which actually provides those services. And then the teams that are building and delivering the software, they become responsible for the SLAs for those services. And that's a key point. If the operations isn't running those services, they cannot be responsible for the SLAs for those services. The product teams, the service teams must be responsible for the SLAs for those services. And what operations provides is an SLA for the underlying infrastructure. And the product teams are responsible for making sure that, given the SLAs for the underlying infrastructure, they can meet their SLAs that they've agreed with their users. There's also not a reduction in the amount of operations people you need, because in this model you have operations people co-located on delivery teams, on product teams. So you still need the same number, if not more, operations people. It's just that not all of them are running in the central operations group anymore. And of course it requires change to the business, because the business doesn't work in this way anymore, where you approve this enormous amount of stuff to build and then you come back 6 months or a year later and see whether any of it actually was useful. The business is actively involved in the complete evolution of services and products as they move through the service life cycle. So I want to talk a bit about governance, because while the things that I've talked about have been successfully proven in several organisations, so it's not stuff I've made up, it's stuff that actually people have done in real life and proved to be successful, there's many objections from the governance crew around this kind of model, particularly around risk management. And I'm not going to talk about all of governance because we only have 20 minutes left, and I want to leave some time for questions. But I do want to talk in particular about the risk management parts of governance. So there's two pieces to risk management. The first part is making sure that you're spending money effectively on the things that add the most value to the business. That's the performance aspect of risk management. Are we spending our money in an efficient way and getting the biggest bang for our buck? And then the second aspect of governance is conformance, making sure that we're not breaking any laws, that we're not going to potentially incur large losses from having people break into our systems and steal our data and so forth. And a number of frameworks have sprung up in order to help organisations meet those goals of good governance. And in particular, the three that I want to spend a bit of time on are Sarbanes-Oxley, ITIL and COBIT. Obviously, I'm not an auditor or a lawyer, so I'm going to give some rough definitions of these things. You should go and consult those if you want those frameworks if you want the real definitions. Sarbanes-Oxley briefly says that anything that has a material impact on the financial performance of an organisation should be subject to controls, and those controls should be audited and known to everyone in the organisation, particularly senior management and the board. So in order to achieve Sarbanes-Oxley compliance, and this is what the particular part of Sarbanes-Oxley that is relevant to IT, not the whole of Sarbanes-Oxley. This is just one particular part of Sarbanes-Oxley. In order to meet that, we have to put controls in the software delivery process to make sure that people aren't committing fraud, that we know what the risks are of the changes that we're making. And those controls are often derived from these other frameworks, ITIL and particularly COBIT. COBIT is all about controls on IT. So the main statement I want to make is that ITIL and COBIT are both compatible with DevOps, and they are both compatible with continuous delivery. It's possible to implement ITIL and COBIT in a way that is compatible with these frameworks. And in fact, continuous delivery and DevOps provide a superior way to implement ITIL and COBIT that actually better achieves the goals of effective risk management and good governance. I want to focus in particular on two pieces of ITIL and COBIT that are often held to be in contradiction with continuous delivery and DevOps. The first one is segregation of duties. Segregation of duties is a control that's mandated by PCI DSS and encouraged by various other regulations. And what it says is that the people who release the software, well, if you actually look at COBIT, what COBIT says, broadly speaking, is that you need two people in order to approve any change. This is a rule that comes from accounting. The idea is that, for example, the person who receives the invoices can't be the same person who writes the checks, because then somebody could write their own invoices and write checks to themselves to cash those invoices and steal money. And the idea is that this applies to software delivery as well, that you need to make sure that any change that's made is approved by someone different from the person who actually built the thing that's being that wants to make the change, so that you can remove the risk of fraud or error. However, segregation of duties often results or implementations of segregation of duties are often extreme, and people sometimes think that segregation of duties means not allowing dev and ops to talk to each other, or putting them in different places and not allowing them to collaborate in any way. And that's actually a very bad idea, because it increases the risk of error and it increases the risk of fraud, and it thus is a poor way to achieve the goals of good risk management. One organisation we work with, they implemented their change management process in such a way to meet the goals of their implementation of segregation of duties using a spreadsheet with 7 tabs. And anytime they wanted to make a change, they had to fill in those 7 tabs and send that spreadsheet to a change manager in a different country to sign off on that change. The change manager had no idea what the risk of that change was, or even what the full significance of the change that was being made was. But they signed it off anyway, because you have to make changes, and they trusted that the developers would probably do a reasonable job. The developers knew that the change management the change management people had no idea what they were doing. So they kind of filled the spreadsheet full of crap. This is a major manufacturing organisation I'm talking about. And the change managers knew that the developers knew that they had no idea what any of this stuff meant, and they knew they were kind of filling it full of crap, because you can't fill a seven-sheet spreadsheet for every change you're going to make in excruciating detail and still actually get work done. And so at this point, what you see is that this is not a risk management process. This is a blame management process, and it doesn't achieve the goals of risk management and it doesn't achieve the goals of good governance. A really good way to meet the goals of good governance and provide transparent risk management is to implement a deployment pipeline. Because when you implement a deployment pipeline, you can see every change as it moves through the system. You can see exactly what that change is in terms of what's changed in the source code, in the configuration of the system, in the database schemas, in the infrastructure. You can see what each of those changes are by looking at the source code changes. And you can evaluate the risk of those changes because automated tests have been run against each of those changes, and the automated tests are what allow you to determine the risk of each of those changes. If a particular change has passed automated unit tests and automated functional tests and has been deployed to a production-like environment and had a realistic load test run against it, and all those tests have passed, you can be pretty sure that it's a low-risk change. So the deployment pipeline provides a great deal of transparency into the risk of the changes that you're making, and it also provides a complete audit trail for each of those changes, because you can see before it gets to production which environments it's been through, who authorized deployments to each of those environments, which tests it's been through, which lines of source code it came from, who checked in those lines of source code and who's responsible for them. And auditors who understand this system love it. My co-author Dave Farley works at a company called LMAX, which is the world's highest performance financial exchange. They use a deployment pipeline, and they have to be compliant with Sarbanes-Oxley and various other regulations because it's a system that handles people's money. And they implemented a deployment pipeline and found that the auditors were very, very happy with it because they got all this information based on real data from real systems, not just pieces of paper which said that people may have done things which they may or may not have done. So the continuous delivery process, the deployment pipeline, DevOps, is actually a superior way to achieve the goals of good governance, and it's supported in ITIL. In ITIL v3, in the section on change management, it says that first there's several mechanisms for lightweight change management. Firstly, there's the concept of standard changes. Standard changes are low-risk, pre-approved changes that can be made without the approval of the CAB. So if you know that a change is low-risk, and it's a pre-approved type of change, you can make it without approval to the CAB, and the deployment pipeline allows you to assess which kinds of changes are standard changes and hence can be pre-approved. ITIL v3 also talks about being able to perform CAB meetings electronically in a just-in-time fashion, so again that can be built into your deployment pipeline. A change can be emailed to the CAB, and the people who are required to approve it can approve it electronically without having to meet. Thirdly, in ITIL v3, there's the concept that not every member of the CAB needs to sign off on every change. It should be possible for a subset of the CAB to approve a change depending on what the change is and what the risk of that change is. And again, if you have a deployment pipeline, you can see what the risk of each of those changes is, and hence decide how many people are required in order to approve that change. There's a lot more that I could talk about on this. I recently co-authored an article for Qatar IT Journal on DevOps continuous delivery and risk management, which is in the August edition of the Qatar IT Journal. I co-authored that with Joanne Molesky. You can get that. We can send out the link to people, or you can just go to the Qatar website and access the journal there. The other books that I've talked about, that's pretty much what I wanted to talk about today. I've kind of covered auditing and compliance. So we're going to take questions now. Just briefly, the other books that I talked about are The Principles of Product Development Flow, Second Generation Lean Product Development by Don Reinertsen, excellent book, and also Eric Ries's book, The Lean Startup. Obviously, I wrote a book as well called Continuous Delivery, which talks about a bunch of the stuff that we've covered today. Let's take your questions.